Right, so just delving into this a bit further. So basically these things here, as you can see, I've removed a few of those. The white pads, you can see it's just they're just like, you know, mounts to, you know, sort of solid heat pads effectively. You can see these things are actually raised mounts. The question that I wanted to answer was, how was that thermocouple added? You know, basically it's just added, they put a channel in there and stuck a thermocouple into the first one. So that's how that thermocouple is actually on. Just on that one. The rest of them don't have a thermocouple actually attached to them. Just the first one there, because they're obviously picking up the temperature of that. I believe that that's these ones on the outside. I've got a thing of how these work, but I think the ones on the outside are the high side ones. So it's picking off the temperature of just one of the high side ones, which gives you, and it's nice that it actually goes right underneath it and it actually detects it probably somewhere close to the actual junction. But it is only on one. I mean, you can't really detect all of them because that's like 32. But it's also, because it's embedded in that, then you will get the temperature of the other ones. If they're specifically very hot, then it should conduct through anyway. But that's how that's done. We're actually down to the bare metal here. So what I'm going to do basically is clean this completely off, and then I'll probably machine it right back to a flat surface so that it'll be a good heat sink. Take away these bumps, and then I can actually add the IGBTs themselves, the modules that I've got on instead. The black it is sort of glued. There's some sort of small, just a bit of bonding agent just to hold the black in place, and the black plastic, it's just basically, it's a former. I think this is so that they can, it's just to facilitate assembly, I think, so they can stick them all in, and they're all mounted in a regimented way using a plastic former. I'm guessing that this is probably heat resistant as well. Yeah, look at this bit. That's obviously where the mess is. Those have definitely blown. There's a few others which have blown as well. I think probably about half of this array has been destroyed. You know, there may be others. There may be some IGBTs which are actually salvageable. I might even do it because it gives me a stock of reasonably good 75 amp IGBTs. Yeah, but I've got pretty much everything. That's right down now. Yeah, because the plastic former's off. The IGBTs obviously themselves off. You can't really remove them without destroying it, which is quite unfortunate really. It means if you have a failure of any of the IGBTs, unless you're fortunate enough for them to be on the outside where you can replace them, but the inside one's not a chance. I'm not seeing any way of being able to access those other than by cutting open the tracks. Now also I've got here the actual laminates themselves, which I'm quite surprised are actually in contact almost, you know, there's just a thin film between them, considering that this is in the original unit. This would have been running at 300 volts. So you got 300 volts between the plates, and look at them, they're actually crushed together pretty much, just with it. So that's going to be capacitance in its own right because of the way those plates are, and the three have got different functions. You can see, there you go. So that one's the one of the terminals which goes to the top plate, and then you've got on this side, you see, that's another terminal which is going to the middle plate, and then the output, which you can probably see from that top one there, the output is actually, I think that's the bottom plate, isn't it? Yes, it is, because you can see it from there, the way it's kinking. This is the other side, because the top one's turned around. Yeah, so and that's half of the, see, I've cut through the hole there. Same on this one somewhere, wherever it is there. So that's how the laminates are actually at. But I understand why they do laminates, but usually they do laminated buses like this, where they're all using the same current, and it's to try and reduce eddies and things. But they've actually used the laminates separately. almost like wires in a circuit. But they are very, very close, and to be honest, I would have said they